Alright, let's talk about automated testing. I know, sometimes it can feel like a chore, right? But what if I told you it's actually the key to building like unshakable confidence in the code you write? That's what we're digging into today. So picture this. Has this ever happened to you? You find a bug, you spend ages crafting this brilliant fix, you push it, and bam, two new bugs pop up somewhere completely different. It's that classic whack-a-mole game, and honestly, it's just so frustrating. And the real problem is just our brains. When we're testing manually, we're focused on the one thing we just fixed. It's pretty much impossible to remember every single edge case and feature across the entire app and retest them all every single time. That's how things slip through the cracks and break silently in the background. But what if there was a better way? What if you had like a whole army of tiny, super fast robots that could test everything for you in seconds after every single change? Well, that's exactly what automated testing is. Okay, so one of the coolest ways to do this is something called behavior-driven development, or BDD for short. And the idea here is it's kind of revolutionary, but it's also super simple. You completely flip the script. Instead of writing code and then testing it, you describe how your code should behave before you even write a single line of it. And here's why BDD is so powerful. It's not just about finding bugs. It's like a 3-for-1 deal. Your tests guarantee the code works, obviously, but they also become the documentation for what a function does, and they're perfect examples of how to actually use it. So you get tests, docs, and examples all rolled into one. All right, enough theory. Let's see this in action, right? We're going to build a really simple function from scratch, powxn, the one that raises a number x to the power of n. And we're going to do it the BDD way, test first. So first things first, we write what's called a spec. Look at this code. The describe block is just a way to group all our tests for the pow function together. Then you have this it block. See how it reads like plain English? It raises 2 to the power 3 is 8. It's super clear what we're testing. And that assert.equal line, that's the actual check. Does pow 2, 3 actually equal 8? That's the question we're asking. But hang on, notice anything weird? We haven't actually written the pow function yet. It's totally empty. So we have a test for a function that doesn't do anything. And that's the whole point. This is exactly where you start with BDD. So what happens when we run this test? Of course it fails. It tells us it got undefined when it was expecting 8. And believe it or not, seeing this red X, that's a good thing. It means our test is working perfectly. It correctly identified that our code isn't doing what it's supposed to do yet. Okay, now for the fun part. The goal right now is not to write the perfect, beautiful pow function. Nope. Our goal is to write the absolute dumbest, simplest, laziest piece of code that will make this one test pass. So, what do? We just return 8. I know it feels like cheating, but trust me, this is a super important step in the process. And would you look at that? We run the test again, and boom, a green check mark. It passed. We've just completed our very first red-green cycle. We went from a failing test to a passing one. Now, obviously, we're not done. Not even close. But this is progress. So, let's be real. Our test is passing, but our function is a total fraud, right? It only works for one specific input. This doesn't mean BDD is broken. It just means our set of tests, our spec, isn't complete yet. We need to teach it more. So how do we make our tests smarter? Simple. We give it another scenario to think about. Let's add a new test case. What about raising 3 to the power of 4? There is no way our current just return 8 function is going to handle that one. Now, real quick, a pro tip on how you should structure these things. You could just cram a bunch of checks into one single it block, but that's a bad idea. It's fragile. Think about it. If the very first check fails, the whole test just stops, and you don't even know if the others would have passed or failed. It's much better to have separate it blocks for each little thing you want to check. That way, you see the result of every single test all at once. And this really boils down to one golden rule. One test checks one thing. That's it. Keep it focused. It makes your tests way easier to read. And when something does break, you know exactly what went wrong. Okay, so back to our code. We add that second test and run the whole suite again. And, well, failure. Exactly like we thought. The first test for power of 2, 3 still passes. But our new one for power of 3, 4 fails hard. It got an 8 when it was expecting 81. See? Our test just caught our cheating function red-handed. All right, now we have a reason to write the real code. The failing test is demanding a proper solution. So we'll go in and write the actual logic, a simple loop that does the multiplication. This isn't just a random implementation, it's specifically designed to make both of our tests happy. So we run the test one last time, and yes, success, all green check marks. Both tests are passing. We just let the tests guide us step by step from a totally broken function to a cheap fake all the way to a correct, robust solution. So let's just quickly recap that whole dance we just did. Step one, write a test that fails. That's your red light. Step two, write the absolute bare minimum code to make it pass. That's your green light. Step three, add another test for a new case, which will probably fail again. And step four, improve your code until all the tests pass. You just keep repeating that cycle, red, green, refactor, until your feature's totally done. Now, I know what you might be thinking. Wow, that seems like a lot of steps for a simple power function. And you're right. But let's zoom out for a second, because the real payoff here, the real magic, isn't about this one little function. It's really about two totally different ways of living as a developer. On one side, you have life without tests. It's a world of, well, fear. You're scared to touch old code. You're terrified that fixing one thing will break something else. But on the other side, with a good set of tests, that's a world of confidence. Your tests become a safety net. You can refactor, you can improve, you can change things without that constant anxiety because you know your tests have your back. And you know what's really amazing? There's this incredible side effect. When you have to write tests for your code, it just forces you to write better code in the first place. You can't test a messy, tangled function very easily, so you naturally start building smaller, more focused pieces with clear inputs and outputs. It just leads to better, cleaner architecture without you even trying. So I'll just leave you with this thought. At the end of the day, are you just writing code or are you building confidence? Because that's what automated testing really is. It's not about finding bugs. It's about building a system, a safety net that lets you be bold, lets you improve things without fear. It's about building confidence, not just in your software, but in yourself.